Hello guys, we're now looking at question number 2 from benchmark 1. The question says the atomic number of krypton is 36. If the mass number of krypton atom is 84, which table shows the number of subatomic particles inside and outside the nucleus of the krypton atom? So what we're going to do is we're going to underline the important information. So then it's telling us that the atomic number of krypton is 36. If the mass number of a krypton atom is 84, so then mass number is 84, which table shows the number of subatomic particles inside and outside the nucleus? So I'm looking for that table. Okay, that is going to give us the subatomic particles that are found inside and outside the nucleus. So then what I'm going to do right here is that I have all 4 tables. In order for me to do this, I need to look at my periodic table and I need to find krypton. And because of lack of time, I don't want to be looking for krypton, but just remember, they gave us the atomic number, which is 36. So the first thing that I did is that I went in order. And I look for that atomic number. So I look for 1, that's not krypton. 2, that's helium, not krypton. 3, and I continue going until I got to atomic number 36. For those of us that are still getting confused as to which is the atomic number, remember that over here we have the key. They use silicon to kind of like get the key, and it says atomic number is the number at the top. Then we have the symbol, the atomic mass, and then the name. So we also need the atomic mass. They gave us the atomic mass of 84. So then krypton, it's 83.7. So it goes, we round it up to 84. So what I was asking you to do in the classroom anytime we had that is that I said, let's go ahead and draw the periodic table box. So right here, just for time purposes, I decided to draw the box. So there's krypton, atomic number 36, symbol Kr, atomic mass 83.798, and the name is krypton. So then what I did, just to make things a little bit quicker right here, I created the I drew the atomic box, and of course I labeled the atomic number, and I also labeled the atomic mass. After I do this, then I say, you know what, I want to know the number of protons, number of neutrons, and number of electrons, because those are the subatomic particles that make up the atom. So then I'm going to put right here A, P, E, because that's going to help me find the atomic number, which we already have right there, but then it'll help us find out the number of protons and number of electrons as well, because A, atomic number, number of protons and number of electrons, like we've said before, they're all the same. So then right here, my atomic number is 36. And we said that all of these are the same. So protons is 36 and electrons is 36. So then I already have 2 subatomic particles. I have the protons and I have the electrons. Now I need the neutrons. How do I get the neutrons? Well, I'm going to ask the man. So I asked the ape, and now the man section. Mass, man, which is the atomic mass, which is this one right here, 83.7. So it's going to be 84 minus my atomic number, which is up here, number 36, is going to equal the number of neutrons. So that's going to equal what I need right here, the number of neutrons. So I'm going to get my calculator, and I'm going to put right here, 84 minus 36 equals 48. So then my number of neutrons is 48. There we go. So now I have my different subatomic particles. Now, remember that in the nucleus, okay, in the nucleus, we find the protons, which are positive, and the neutrons, which are neutral. Okay, so they have no charge. So in the nucleus, I need the total of subatomic particles, because it says right here, number of particles inside the nucleus, number of particles outside the nucleus. So that's what it says right here, inside and outside the nucleus. So whatever's outside the nucleus, that's what goes into the electron cloud. So then in my nucleus, I need the total of subatomic particles, protons. So then right here, protons is going to be 36, and neutrons is going to be this one right here, 48. So when I add these two, because they're the ones that go in the nucleus, I'm going to say 36 plus 48 equals 84. So then 84 subatomic particles, a combination of the protons and the neutrons, go in the nucleus. So then right here, we have the 84 subatomic particles that go in the nucleus, which means that now we need to look at the nucleus. We have 36 right here, so that's not it. We have 36 over here for B, that's not it. So that's out, that's out. And we have 84 and 84. So this is correct, and this is correct. So then that's 4 particles inside the nucleus, just like we listed right here. Well, we have the protons, we have the neutrons. Remember that for the subatomic particles, we usually say PEN. P-E. So then we already have the protons over here, 36. We have the neutrons, which are 48. Now we need the number of electrons. So then if I look right here, my number of electrons are going to be 36. So then right here, I'm going to put electrons, which go in the electron cloud, which means that they surround the nucleus, they go outside the nucleus, is going to be 36. So then 84 inside the nucleus. There we go. These two could be it. And 36 outside the nucleus. So it's not this one. It is going to be this one. So my correct answer is going to be letter C. Thank you very much, guys. Make sure that you copy this onto your question. See you. Bye-bye.